Graphing transformations. Graphing transformations. And I only really had you look at that page so you can see the 4 different transformations they're going to talk about. And they are a reflection, a rotation, a what? Translation, and a dilation. Probably the only one that might throw you for a little bit of a loop, at least in this. Dilation just means it gets bigger or expands. And I suppose it could get smaller if you dilate it by a fraction, because that would actually make it smaller. But lucky for you, I have a piece of paper that I want you to look at here. This is why you have the ruler, so we can do this kind of thing. Most of this is relatively easy. And I think, let's start with the easy and work our way up to Aubrey's doodling part. Because that was complicated. Aubrey, I'm a doodler from way back, so I really don't care. They say the most intelligent people don't doodle. No, doodle. But you're a doodler. Let's start with the easy and work our way to the difficult. Look at problem, let's go to number 2 on that sheet there. And this is why you have your ruler, so you can actually do this correctly. I'm going to try to find number 2 on mine. This it? This it? Don't give up hope, kids. It's here somewhere. There it is. Number 2, children. Starting with the easy ones first. Translations are incredibly easy because all you have to do is follow the simple little rule that it tells you. Translation just means it slides from one point to another. This gives you, it says you go 4 units to the right and 1 unit down. So you find the little vertices or the points there and you just do what it says. 4 units to the right, 1, 2, 3, 4, and 1 unit down puts this Y, which we label affectionately what over here? If this is Y, what should we call this? We call it Y, this little mark up there means it's called Y prime. Just so you know that it corresponds to Y, but it's not Y, you put that little mark there. It's not Y to the first power, it's called Y prime. Then you do the same thing for all the other points. Point G, 1, 2, 3, 4, down 1, so that's Mr. G prime. And F, 1, 2, 3, 4, 1 down, and that's F prime. And then, of course, you have your ruler, so you, along with me, can draw your little translated triangle. Yours will be better than mine because I'm limited with technology. And then the whole shape has shifted 4 over and down 1. Does anybody have issues, problems, cares, concerns, anything with that? Most of you will be pretty happy about that, aren't you? This is like fun math, but it's not like you have to calculate stuff. It's kind of like connect the dot puzzle. The next easiest thing, children, is going to be, let's do the reflection. Because I think that's probably the next easiest. All right. I believe that's problem number 4 on your sheet there. First of all, what is your reflection point? What are you reflecting about? In this case here, we're reflecting on the x-axis. So that's good. The first thing I would kind of do is make sure I highlight that. This is where what we're doing a mirror image of. Okay? And this is kind of how this works. If I am looking for point K prime, okay, point K prime is going to be the same distance away from your reflection line in the opposite direction. In other words, this, okay, point K is 1, 2, 3, 4 down. So when it gets reflected, it's going to be the opposite of that, and from this point it's going to be 1, 2, 3, 4 up. So this is where K prime is going to be. Letter M prime. Uh-oh. Is it 5? 1, 2, 3, 4. This is my axis point right here. Now, if you're thinking this is the axis, yes, it would be, but you don't. This is not what you're reflecting on. You could, by the way, reflect on this axis here, which would be where y is 1, but we're not going to. M, from this point here, and think about, you want to form a right angle here, by the way. You're going straight down 2, so you want to go straight up 2. So that is point M prime. And you could, for grins, if it helps you keep things straight, you could connect those 2 points just so you know that you've made this reflecting point right here. Now here's where you probably would go wrong here. There's a little goofy intersection point going on here. Notice that point C is 1 up from here. So the opposite of 1 up is going to be 1 down from there. So right here is going to be C prime. And same thing here. J is 1 up, so you reflect it on that axis, it goes the opposite direction. This is J prime. And there are your 4 points, which I'm sure you're excited about. Shabam, shoobam, and shoobam. And there is, if you folded that, if you flipped it about that, I can't say fold because it wouldn't look like that, so it would match up. But if you flipped it on that axis and turned it over, that's what it would look like. That is your reflection. You should probably try. Is there another reflection? And now let's do what I consider to be the most difficult of all the ones, which is number 1, a rotation. Rotation is just tough to, it is tough to get a handle on rotation. And I'm not sure I've come up with a great way to explain it, so I'm going to try the best I can. Okay. First of all, what are we rotating? We are rotating 90 degrees counterclockwise. For those of you that don't understand clockwise or counterclockwise, think of a clock. Clockwise means it goes the way the hands of a clock would go, which would be this way. This is clockwise, because that's the way a clock turns. Counterclockwise means it goes the other direction. That's counterclockwise. So I am going 90 degrees counterclockwise about the origin. So here is my origin, and you have to think about this like this. This would be if you stuck a pin at the origin and turned the paper 1/4 of a turn, because 90 degrees is 1/4 of a turn. How would this shape turn and look over there? Well, here's what you have to do. If you're turning at 90 degrees, the x-axis right here actually ends up turning into the y-axis right here, because that's a 90-degree turn. So this point Z, if you are looking for Z prime, is going to be that same distance away from the origin there, except on the y-axis. 1, 2, 3, 4. 1, 2, 3, 4. Here is where Z prime would be. If you took this piece of paper and you rotated on that thing, on that point, it's going to be there. Now when it gets tough, it's easy if it's on the axis, but how would I find J? Well, think about what happens right here. What is J? J is 1, 2, 3, 4, 5 over and 1, 2 to the left. So it would be the same thing here except 5 down. 1, 2, 3, 4, 5 and 2 to the left. That point, if you swung at 90 degrees with reference to the x-axis, is going to end up looking like that. So you've got at least these 2 points. What is L going to be? Well, if I turn this 90 degrees 1/4 of a turn, Now the y-axis actually ends up being where the x-axis is. So point L is going to be 1, 2, 3, 1, 2, 3. That's L prime. And now you have your 3 points. Everybody's pretty happy. It's not quite as simple as, and sometimes it might not hurt you. You know, if you were in a bind and tried to figure it out, if you were in a bind, you probably, how could you actually do this without, nah, maybe it's not the right time. But do you kind of get the gist of that? Always look at kind of in terms of your axes. Where's another, is there another rotation here somewhere? Yeah, look at problem number 9. Go all the way to problem number 9. And the first thing you need to do is to draw, before you rotate it, you need to draw the shape they gave you. So take those 4 points, please. Take those 4 points and plot them. That's our mathematical word. And draw the straight lines and see what shape you get. Take those 4 lines, draw them, see what shape you get. I'm going to try to find this on my paper here so I can. What number did I say? 9. Yeah, 9. Number 9 on this piece of paper, please say yes. Number 9. There it is. Number 9. Bro, I know. Here we go. Number 9. Give you a second to do that one. There she is. If you don't get your points plotted right, you're probably going to get a little bit hurt, so you might want to make sure that happens. -2, 0. And you make sure you label them, because otherwise you're still in the middle. Oh, that's a great shape. Did your shape end up looking like my shape? Oh. Yes? Or no? Yes? Yeah. Okay. So, I wish I could put those together. It's hard. I can't. Even through the magic of the board, I can't figure out really how to do this. I don't think. Do you think I could? I don't think I could. Maybe I could. Who thinks I can? Don't raise your hand because I don't think I can. I'm going to try. Let's see what happens if I do this. If I cut and paste this, if I use my favorite tool, which is the snippet tool, and I make a copy of this, and I go back to this, and I paste this there, right over top of it. If I'm rotating it about the origin, now the problem is, can I make this so I can see through it? Oh, look at that. Let's see one more, let's go a little lighter. Is that too light? Get a bunch of liners. Let's go 50%. Okay, so here would be the gist. Let's see if I can do this. First of all, I got to try to get to match up. Please. Okay. Sorry. I don't get so good. Okay. So there it is. If you're rotating, here's the problem I'm going to have. If I rotate this about the origin, okay, I don't think this is going to be exactly at that point, but we'll try. What should happen is, instead of this being, and I'm going this way because it's clockwise, instead of this being the x-axis, it's going to rotate 90 degrees, and that point here is going to end up right there and actually be the y-axis. So here is what our final product is going to look like. I got to move this back down. When I rotate that, that is what my final product will look like. But I'm not going to do it like that. I'm going to actually get rid of this for now and actually do it. So here's what it looks like. Let's blow this bad boy back up. Okay, so again, if I'm looking for B prime, notice it is 2 points away from that, or 2 places, 2 units away from the origin. I spin it, so my B prime ends up being right there. I'll change colors. Okay. Now, how am I going to find? Oh, I didn't label those. Why didn't you guys tell me I didn't label those? What is this? Z? Is this Z? Yeah. This is Z and this is X. Let's say I was finding X. Okay. Now, if I spin this, where is X actually going to end up? Remember, the x-axis is becoming the y-axis, and the y-axis is going to become the x-axis. So if I take this whole line and cut it and turn it over here, okay, if I go 1, 2, 3, 4, 4 over and 1 to the left, 1, 2, 3, 4, and 1 to the left, that would be this same spot corresponding, right? Yep. Is that what it is? X prime. Yep. Same thing with Z prime. If I look at it with respect to this axis and see it's 1, 2, 3, 4, and then 1, 2, 3 up, 1, 2, 3, 4, 1, 2, 3 up, I believe it ends up being right there, Z prime. And then letter C, you could do it either way. I could turn this axis point here at 1, 2, 3, 4, 1, 2, 3, which turns into 1, 2, 3, 4, 1, 2, 3 there. That's C prime. Does that look like the same shape or different? Say yes. There, 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 there. Was that what it looked like when I spun that thing? If I rotated 180 degrees, okay, this axis would just flip and turn. It would be the same. It would still be 2 points away from here, but everything would go down from there. This point would turn into that point, and then the whole thing would get spun, and the little triangle would be pointed there. Rotation, by far, to me, is the hardest of all the translations. I don't know if there's any. Does any of these say that there's a dilation? No. Look at problem number 5. What would you say, what is the rule for number 5? Does this give me 5? Uh-oh. Is that 5? That's 6? Do I not have 5? Don't worry, I can find 5, don't you worry. I know you were very concerned about that. Somebody tell me what they think the rule for number 5 is there. First of all, you have to ask yourself, is it a rotation, a dilation, a reflection, a translation? What is that? Is that thing spun or is it just moved? Drew Norquist, it is? Translation. It's a translation, and what is the rule? Now remember, it started with these numbers that don't have the prime. The black went to the blue, so what is your rule for the translation? It just did what? It just to the right. 1 unit to the right is your translation. Now, how about number 6? That's where it gets a little strange here. What type of a transformation is number 6? Elijah says it is a reflection. Wait, I'm going to snip it so I can draw on it here. Move it over here. The question is, what is it a reflection? What is it being reflected on? And how do you know? Well, remember, reflection, you have to have half on one side and half on the other side of it. Elijah says, well, it is in the first quadrant, but I don't know what quadrant plane 1 means. Where is the line of reflection on this? Where has it been split so that it kind of look reflected about it? You just kind of go look and see half. Look, take a look here. See these two, D and D prime and P and P prime? If you think about halfway between those, right here, that is your axis of reflection. It reflects right there because all of the primes are opposite of where their not prime numbers are. Now the question I would ask you is, how would you tell me what that axis is? It's reflected about what? Anybody know what that is? If you're trying to tell me that that's your axis of reflection, what would it be? Where what is what? You know, if it was right here, it'd be the y-axis would be my reflection. If it was here, it'd be the x-axis. But it's not. It's this vertical line right here on this graph. What is that vertical line called? I'll entertain some guess. Shoot, you must have some sort of a guess. When I'm graphing a line, what is this line called? If I were to graph this, if I were given a coordinate system, and there's my x and y axes, and I drew a line right here, what is that line called? Vertical lines are what? Mitch says?
Line of symmetry.
Well, yeah, it's my axis of symmetry. Yes, it probably is, but that's not. I wanted you to tell me what that axis. What value is that axis? Tyler, any idea? Isabel?
Y3.
Yeah, exactly. It's about y. The axis is where y equals. No, it isn't.
Oh,
You're close. Well, I was thinking it's kind of backwards from what you think. This is actually, what point does this cross right here? What is this? That is not y equals 3, but that is the point x equals 3. Is it not? Here's my x-axis. 1, 2, 3. It crosses x. It doesn't cross y at all. The axis point is where x equals 3. If you were to graph here, if I told you to graph x, well, I need a piece of graph because this isn't logical for most people. I can't go there. I like it. Nah. Here, let's do this. If I told you to graph x equals 1 on a coordinate system, here's the deal. If you're graphing x equals 1, it doesn't matter what y is, x is always 1. So if you're making your little chart table here of x and y values, what's x? X is always 1. What y? Y can be anything. 0, -2, 6, 4. If you're graphing these points, watch what happens. 1, 0. Here's 1, 0. 1, -2. 1, -2. 1, 6. 1, 1, 2, 3, 4, 5, 6. 1, whatever I put there, 4. This is the graph of x equals 1. Guess what the graph of y equals -2 is? No matter what x is, y is -2. Where is y -2? Right here. This is the graph of y equals -2. I can tell you're very excited about that. We should ask for one more here. So, with that in mind, look at problem number 7. Problem number 7. What is the axis of reflection for problem number 7? Look at the primes and their numbers and then split it halfway in the middle. Where does it look like that thing is rotating about? Please tell me somebody besides the lines that has some idea. Colquitt? No, not the origin. The origin is a point. It's not a line. Shoot. -2x. -1, -2. Here's -2x. I missed it. I can't do that. Let me snip it and show you. This is what Jaden said. He said -2x. Here's where -2x is. -2x. Here's the origin, -2x. Here's -2x. This is that. Does that look like where it's reflected? look at R and R prime, think where's halfway between them, F and F prime, where's halfway between them. Josh,
X equals 4.
here's x equals 4. 1, 2, 3, 4. X equals 4. Carol Winkleman.
X.
Huh?
X equals 0.
Well, x equals 0 is right here. You're close, you just have to say it right. The x-axis, which is this. This is the x-axis, this is the y-axis. It is reflected around that axis right here. The x-axis, by the way, is where y equals 0. If you told me y equals 0, that's the x-axis. Was that what you were going to say, Mitch? Yeah, because y is 0 at that point, all the way across. That's the x-axis. Perfect, children. Then your assignment is to do the rest of these, whatever problems they are. I think you'll enjoy them. Band people, where are you at? Who just came in?
14.
Okay. Whatever we haven't done. 9 through 14. 10 through 14. Yeah, well, yeah, you're gonna do graph paper. Okay, well, just do problem number 10. Let's just go problem 10. Good. I'm gonna have to tell you that. Listen carefully. You can't do number 10 unless you get this one small little tidbit of information here. Did I even start this? Well, let's put it up there. Number 10 says to reflect it about y equals x. And here's what you got to think about. Here is my x and y axes. All right. Here's my x and y axis. Oh, wait a second. I think it's going to be this. Hold on. Yeah. Here is my x and y axis. So, people have to start thinking outside some sort of box here. Okay, that's not going to work. Would it say y equals x or x equals y? Y equals x.
Y equals X.
If you make a table where y equals x, if x is 1, what's y? If x is 0, what's y? If x is -2, what's y? So if you graph that, that's the axis you need to reflect it about. Here is 1, 1. Here is 0, 0. Here is -2, -2. This is your reflection axis. It's a diagonal line that goes right through the origin, 45-degree angle, y equals